Is Caleb Keener, and this is my Physics 2211 Lab 4 Oscillations. To begin with, the purpose of this lab was to observe and analyze a spring mass system. From that, we would compare our predicted motion from our glow script code to the observed motion from tracker. We'd then plot the change in position of predicted versus observed motion, and then plot the change in energies from the predicted values. And just a preview of the results, the change in total energy was always 0 throughout the experiment, and the predicted positions were very similar to the observed positions. Continuing on, we did use Newton's second law on this. Then we used the net force equations, F net equals ma or F net equals dp dt. We also used the velocity update formula, which is Vf equals V initial plus F net over m times delta t. And we used the position update formula, which is position final equals position initial plus velocity average times delta t. The most important thing, though, is that we use the energy principle. The energy principle says that the change in total energy of a system is equal to the work done from the surroundings plus the heat exchanged. It also states that the energy is neither created nor destroyed. In this lab, the system is the spring, earth, and the block, and the surroundings is everything else, in this case nothing. Since there's nothing in the surroundings, there's no work done on the system, and therefore the change in total energy throughout should equal 0. Some important equations to remember is change in energy of the system equals work surrounding plus heat transfer, or in this specific scenario, it is change in energy of the system equals change in kinetic energy plus change in gravitational potential energy plus change in spring potential energy. And here are the respective equations for each. Kinetic energy equals 1/2 mv squared, gravitational potential energy equals mgh, and spring potential energy equals 1/2 ks squared, where s equals compressed or stretched length minus relaxed length. So here's the tracker video. As you can see, I set the origin of the axis equal to the base of the spring, and this calibration stick is equal to what the video gave me, 0.7 meters. And then here you can see that the x and y position is on an oscillating curve, and so it has periods where it reaches the same max x position and max y position. And then here are the time with the x and y positions. So for the predicted motion initial conditions, from tracker we already get the mass of the ball is 0.402, and the initial position is negative 0.113, negative 0.620, and 0, and then the ball velocity is 0 at the start. From the pre-lecture video, because I used the pre-lecture video in my lab, I got the spring constant equal to 6.83 and the relaxed length equal to 0.123. So here's my glow script code. As you can see, here I calculate L hat, and S, and this helps me calculate the spring potential energy. Then here I calculate the kinetic, gravitational, spring potential, and then the total energy. And then moving down here, I set what the initial energies for each of those are. I calculate the force of gravity, the force of spring, and F net. Then I use velocity and position update formulas to update them. And then carrying over here, I calculate the change in each energy so I can calculate the total change in energy. So here are the graphs from my lab. Here's the graph that graphs the kinetic, gravitational, spring potential energy, and the total energy. And here you can see that spring and gravity are opposite. Delta K is oscillating, and the total energy is constant throughout. And then here is the observed versus predicted position versus time graphs for x and y position. And as you can see, they're very, very similar. However, x and y are slowing down in the observed, whereas it's in a perfect system with no drag. The model is not slowing down at all. It's keeping a constant time and period. Continuing on, what does it mean? Is the energy principle satisfied? In this lab, yes, the energy principle is satisfied. This is because the change in spring potential energy, gravitational potential energy are opposite, and kinetic energy oscillates, so the change in energy is equal to 0. In other words, the sum of all the energies in this lab is equal to 0. And the energy principle states that the total energy cannot go up or down, and it must stay the same. So the energy principle is satisfied. And continuing on, what does it mean? In this part, we had to determine the periods for the x position and the y position and then discuss. And I found that the average oscillation period for the x position is 1.614 seconds, and the average oscillation period for the y position is 1.519 seconds. This difference could be due to unaccounted forces such as drag force or our own human error when using tracker. Thank you for listening to my lab.